Hey guys, this will be the first ever video on this YouTube channel. To lay some groundwork, this channel will have DSA, operating systems, networking, concepts like that, stuff that I learned because I'm still in my second year. So stuff that I learned, I guess I'll just make a video of it. So people who are younger can learn, and people who might be older but need some help can find help, I guess. Today's main topic, sliding window. I'll do a LeetCode 2302, which is a hard question according to LeetCode, and I'll talk about the template that I use to approach sliding window questions, and just how, I guess you could say, easy it gets once you understand the template, right? So template, let's say I'm a company, and let's say I'm the manager. There's a person above me, boss, and I have this group of engineers that I manage. And the boss, I have to take the boss's instructions seriously, otherwise I'll lose my job, right? And let's say we have this project that we're supposed to do. We've done it. Let's say it works perfectly well, but there's 10 people on my team right now. That's 10 people I'm paying, let's say 100K. So the boss here is like, the 10 people and 100K is too much. I think we should, fire some people and make it like as cost effective as possible, let's just say. So since I'm scared and I don't want to lose my job, I'll say, okay, now let go of one person. The project still works, right? That person wasn't so crucial, I guess. I go down to 8, still works. Go down to 7, it still works. Go down to 6, still works. Go down to 5, now the project stops working. Now, do I just sit here and not let the project work? Or do I hire people? And of course I'll hire, right? Because the boss will be unhappy if the project isn't done. He'll still fire me. So I'll hire some people again. 7, 8. Now I see that on 8 it works. The project works. But my boss is, greedy person. He says, oh, if it works on 8, why don't you just cut again? Who knows? You might hit the jackpot and we might save the most amount of money. And so we just keep doing this. Like we just keep hiring and firing people. And that's, I guess, what sliding window is as well. It's really just if you have some condition, okay? Let's say it would be the opposite of this project. I guess this project is kind of like showing you how, like, why we hire and fire people, but it's a bit opposite in sliding window. I'll show an example. It will simplify things a lot more. Let's say we hire people over here. We hire one person, and in this scenario, when the project, let's say, doesn't work, then we fire people. I mean, I know I said, like, when the project doesn't work you would hire, but in some situations, if the project also doesn't work, you might want to fire some people, and you might want to rehire. I mean, I guess you could just have it be, it'll look more simpler once I go to 2302. It's a bit opposite to your intuition, I guess, once I've shown this example, but just hang on. When project X, then we fire people, right? When project isn't working. But when project is working, we will report to our boss. Let's say we'll go to our boss. We'll say, hey, we have this many people And right now the project works, right? Because when the project wasn't working, we were in this condition. When the project is working, we're in this condition. So we would say, hey, we have this many people and project works. And the boss will be like, okay, very nice, very nice. Just like I said, it's a cycle. So he'll be like, okay, go back to doing your work. It's just that I'll show like the template in like a high level version of the code, so pseudocode. It would essentially be, let's say until we have an array, let's say we have an array. It has a lot of elements. We can pick from these elements, right? And what we'll do is, well, we can keep picking. We'll keep having. And when people we've picked don't work, we'll fire them. And when they do work, we'll update something, right? And it's literally the same with sliding window. So I guess the best way to go about it is literally just to solve Truth 302 already. I'll show you what I mean by this. So we have an array, right? We have to find the score, which is the length of the subarray we are at times the sum of the subarray we are at. Now the naive solution would be like your thought process would go, okay, sum. Okay, so we would have to do a for loop for num and nums. I would add it to some sum. I'll use that sum and I'll bring it here, and then I'll use it at the length and I'll bring that here. I'll see score and I'll check if it's S and K. If it is S and K, then I'll say, okay, I guess I'll keep this length and I'll update that. But what if we didn't have to do this every single time? And that's kind of like the idea sliding window brings in. Let's say we have a running sum now, and we set that to 0, right? Since this is a dynamically sized array, low equals to 0, high equals to 0. Now do keep in mind, if it is fixed size, you can have it just be k minus 1, k being the length they've given. I'll come back to this actually, so I'll come back to this once I solve this question. But low equals to 0, high equals to 0, we have some counter that will be our result, right? Okay, since we're supposed to count the number of like lengths that we have. Now what we want to do, like I said, while we can keep picking, so while we can traverse through this array, we'll keep hiring, right? And how do we hire? Now the way we hire in sliding window is running sum plus equals to nums high. Now there's one thing you should take away from this video is hire, we do it with our high. Fire, we do it with our low. Hire and fire. HH, just remember HH, high with our high. Okay, and in this question we also have to do length, right? So you'll say length equals to minus low plus 1 because it's offset to 0. And now since I said, hey, and the people we've picked don't work, as in the window that we are in doesn't satisfy the condition. Now what was the condition? Like I said, Score is less than k. What is the negation of this? This is a logic loss negation operator. Just what is the opposite of this statement? That's greater than or equal to k, right? So, wow, this thing that we're on, like the people we've hired right now, like they don't work. So we just say, okay, length times the running sum, because that's what score is, right? Is greater than or equal to k. We want to fire people. Now, what did I say about firing? You'll fire from a low. Same thing. And obviously you would increment, right? If you have an array that you could pick from and you've hired, and you go forward and you bring it, and let's say you've hired till here now, and the window condition no longer is met. You would fire, and then you would bring your lower pointer here, bring it here, because you wouldn't just keep firing this guy, right? Like he's not there, so of course you wouldn't fire. So now counter plus equals to length, because that's what they want. Now do keep in mind, we definitely have to change length. We'll have to recalculate it here, right? Because we calculated it outside the loop, and we did change running sum already, but we didn't change running sum. Yep, we changed running sum already, but we haven't changed the length, so we'll have to recalculate it, and otherwise we would just be stuck with one length, and that would lead to wrong answers. Now, like I said, once you're out of that window, we're in the correct condition. So right now we can tell our boss, like, hey, it works, right? So we say okay, and our result will just add length, and then we'll increment our pointer to hire the next person. So, bring it here, hire the next person in the line, and then we'll return this counter. Now if you run this code literally as is, it already passes, but I guess I'll sum it up. So the main thing we do, we hire, right? We hire from our high. When it's invalid, when the window, then we fire. And we fire from our low, and then we increment it as well. And then once we're in the condition that the window is actually valid, we add it to a result, or like we update the result, as I say, and we just move on to the next person once this loop ends, because high will reach the end of the array. You just return the result. Pretty simple. Now why does this work? Let's see. I'll simplify this example to not have length. Let's say we have this array here, and right now I include the running sum of this, right? I say, okay, this running sum is working. Okay, it's working. We will say, okay, so the length we have right now, we have the most minimum we could find was 1, right? No, actually it would always stay 1 if we say it as, okay, maybe let's simplify this a bit. If we say it works with 1 and we're trying to maximize the length, let's say, and I found 1, right? So I'll say, okay, the current maximum is 1. I slide the window over, I add one more element, I hire one person, right? That's what the condition is, If the window is correct, just update your result, add one person so that you can bring the next person in. It works right now as well. It works now. It's actually 2, right? The length is 2. We have 2 elements, and then I hire another person. So, but now when we hired this third person, we've had an issue. Our thing, like our, let's say some is not meeting the condition that they've set up. Now it's an issue, right? Because that's not your answer anymore. So what you'll do is you'll start circling this part out. You'll come here, but you see that it doesn't work for this either. Or wait, if it works for this, let's go back to working for this. We see that it works for this one single element, and so it's like, okay, so I guess we could say like it's strictly equal to something. We could set some condition like that. It's off the top of my head, but I'm just gonna explain why this approach, right? If let's say this element does work, then we can add it to our maximum, and you see how we've just slit the window, but we've considered 1, 2, 3 elements. We've considered the idea of having this as a only subarray. We've considered the idea of having these two as a subarray. We've considered the idea of having these two as a subarray. This alone and the whole thing, right? So we've calculated a lot of subarrays with just this. And I guess this pattern just simplifies that idea of thinking that, oh, if I find this element, then I have to compare with the rest of the array. No, you can simplify it, right? You can just have a running sum and then just add high, subtract the low. Now we've considered a new subarray, and it's essentially just that. Now, like I was saying, for fixed size, low equals to, I'll just start here. Now I'll encourage people to actually just go and do the fixed size arrays, like the questions themselves, because I don't think there's any hard LeetCode sliding window questions that does fixed size and has it hard. It's all easy to medium. So I would say, like, if you watch this video, right, and I guess this is kind of like the key takeaway for all of this. If you just do this with one constant window of like length 3, let's say I have this box of 1, I'll just slide this box over, that's it, you know? It's literally just that. Slide the box over, see if it makes the condition. If it doesn't, then no, then fire. If it does, then hire. And if you do run into issues with this, just I'll go over a question that does fixed as well, if that's something you want. But I feel like this is something you guys should attempt. Solidify this, the idea of why sliding window, and you will see that I would say it's the easiest. I will not say the easiest, because LeetCode can get hard, but the easiest pattern. But that's it, yeah. Thank you.